Lewis concept of acids and the bases. According to the Lewis concept, acid is a substance that accepts an electron pair. So we can say electron pair acceptor is an acid, and a base is a substance, a molecule which can donate an electron pair. So we can say a base is electron pair donor. So the main idea about the acids and the bases, as per the Lewis concept, is that there should be a coordinate bond, right? Because when we have a coordinate bond, we have a this acid and a base. We have an electron pair donor and electron pair acceptor. So that means if we have a substance, suppose we have a molecule B and it has an electron pair, a lone pair of electrons that it can donate, and we have an atom A that can accept this electron pair, and if this B atom, it provides this electrons, it's a donor, and A accepts it. So that means, as per the Lewis concept, a molecule which is capable of accepting an electron pair is a Lewis acid, and a molecule which can donate the electron pair is a Lewis base. So let's take here an example. If you look at the ammonia molecule, NH3, nitrogen has three lone pair, a lone pair of electrons and three hydrogen atoms there. And if it reacts with the hydrogen ion, H plus ion, this electron pair from the nitrogen can form a coordinate bond with the H plus ion. So that means the ammonia molecule can donate electrons, and H plus ion, it can accept electrons and form a coordinate bond. So therefore ammonia molecule is a Lewis base here, and H plus ion is a Lewis acid. So if you look at a reaction between the H plus ion and the hydroxide ion, also in this case we see that there is a coordinate bond formation between the hydroxide, between the oxygen and the H positive ion. So H positive ion, it has electron pair, it can donate, and therefore it acts as a base, and H plus ion will accept it, so forms a coordinate bond, and therefore this is a Lewis base and this is a Lewis acid. So according to the Lewis concept, you can say anything that can accept electron pair is a Lewis acid, and any molecule, any species that can donate electron pair is a Lewis base. Let's take another example. Ammonia molecule, it has a lone pair of electrons, it can donate it, and the BF3 molecule, boron trifluoride, this boron has actually 6 electrons in its valence shell, so its octet is not complete, and you can see that this boron is actually 2 electron deficient, and therefore ammonia molecule can react with the BF3 molecule and can form a coordinate bond. Nitrogen with the lone pair of electrons, it can donate and form a coordinate bond with the BF3, and the BF3 molecule accepts electrons, so it is a Lewis acid, and ammonia, it donates electrons, is a Lewis base here. So any molecule that can form a coordinate bond, that can actually donate electrons, is a Lewis base, and a molecule which is electron deficient and can accept an electron pair is a Lewis acid. So let's take here some more examples of the Lewis acids and the bases. AlCl3 is a very common Lewis acid that we use. Okay, this is a Lewis acid because it is aluminum with the 3 chlorine atoms. Okay, and you can see here again its octet is not complete, therefore it can accept electron pairs which are being donated by any molecule which has a lone pair of electrons. So AlCl3 can form a coordinate bond, it can accept electron pair, so AlCl3 can act as a Lewis acid. This is a very common acid that we use in the organic chemistry. In most of the organic reactions, whenever you see a Lewis acid, it is the AlCl3. Similarly, if you look at the carbon dioxide, okay, if you look at the carbon dioxide, Carbon dioxide can also act as a Lewis acid, because in the carbon dioxide we have a carbon double bonded with the oxygen, and due to the resonance in this molecule you can write down the resonating structure of the carbon dioxide like this: carbon single bond oxygen, oxygen with the electron pair negative charge. It has already 2 electrons, right? 2 electron pairs there. So when resonance takes place, these pi electrons, they will shift towards the oxygen, because oxygen is more electronegative atom, so it will have a negative charge. Carbon will be a positively charged, and then you can have a double bond over here, and then you can have a one more resonating structure, where you can say this electron pair goes down here and this shifts here, and then again you can say you have a double bond here, a single bond here, a negative charge here, and a carbon with a positive charge. Now because of the positive charge in the carbon atom, okay, it can actually interact with the hydroxide ion. Okay, it can interact with the hydroxide ion, because hydroxide ion has electron pairs, and this hydroxide ion can form a coordinate bond with the carbon, okay, because carbon has a positive charge, and then it forms a molecule like HCO3 negative here. HCO3 negative is the molecule that you get when the carbon dioxide reacts with the hydroxide ion. So therefore here in this molecule, in this example, hydroxide ion is an electron pair donor, so it's a Lewis base, and the carbon dioxide, which accepts an electron pair, so it's a Lewis acid, right? So hope you got the concept. Thanks for watching the video. Bye for now.